This integral is very important when it comes to calculus applications because it often appears in problems where we have to calculate an area which depends on a circle. So let's solve this integral. First, let's see what is the area where this integral is defined. We have a square root of a squared minus x squared, and that means that a squared minus x squared has to be larger or equal to 0, so this square root function would be properly defined. Well, this basically means that a squared is larger or equal to x squared, and that gives us that x has to belong in an interval from a minus a to a. Now I'm going to show two methods how to solve this integral. First method is going to be by using a substitution. So we have an integral of square root of x squared minus x squared dx. Now when we introduce this substitution into a problem, we are trying to get rid of this square root function. Now that can be done by introducing a substitution as x is equal to a times sine of t. Well, this basically leaves us with a differential of x being a differential of a times sine of t, which is then equal to a times a differential of sine of t. That is then equal to a times cosine of t dt. This integral is then equal to a square root of a squared minus x squared is a squared times sine squared of t times differential according to x is a times cosine of t dt. This is then equal to a is a constant, so it can go in front of a sign of an integral. And then we have a square root function. A squared is common in both of these terms, so we are left with 1 minus sine squared of t, cosine of t dt. This is equal to a times an integral. Square root of a squared is absolute value of a times the square root. 1 minus a sine squared of t is cosine squared of t times cosine of t dt. This is then equal to a times an integral. Absolute value of a is only a because a is a positive number. Square root of cosine squared of t is an absolute value of cosine t times cosine t times dt. Now the question is, what is an absolute value of cosine of t? So we have that x belongs in an interval from a minus a to a. And we have that x is a times the sine of t. Well, this basically means that sine of t is equal to x over a. And since x belongs in an interval from a minus a to a, that means that sine of t belongs in an interval from minus 1 to 1, which is not a big surprise. Now this is the fun part. Since sine of t is equal to x over a, that means that t is arccos sine of x over a. And arccos sine function is defined on an interval from a minus p half to p half. Well, in a trigonometrical circle, a sine value is read from a y-axis. Basically, we have 0 here as the beginning of Descartes' coordinate system. We have 1 here and 1 here. Now, whichever value x over a is, that means that we can take an angle of t, and that angle of t belongs in an interval from a minus p half to p half, so that sine of this angle t is equal to x over a. Now from a minus pi half to pi half, which is this interval right here, we see that the cosine value on that interval is always larger or equal to 0. Well, that basically means that cosine of t is larger or equal to 0 for every t which belongs in an interval from a minus p half to p half. Now, when we return into this step of our solution, we get that a squared times integral cosine of t is always a value which is larger or equal to 0, so its absolute value is that value itself. Times cosine of t, we get a square here, and that is dt. A basic trigonometrical identity states that cosine squared of t plus sine squared of t is equal to 1, and we know that cosine squared of t minus sine squared of t is equal to cosine 2t. This is a trigonometrical formula for a double angle. So when we add up these two identities, we are going to be left over with 2 cosine squared of t being equal to 1 plus cosine of 2t, which means that cosine squared of t is equal to 1 plus cosine of 2t over 2. We can return this into our solution, and then we are going to get a squared times an integral 1 plus cosine of 2t over 2 dt, which is then equal to a squared over 2 open bracket integral of dt plus an integral of cosine 2t dt closed bracket. Well, this is then equal to a squared by 2t plus an integral of cosine 2t dt. So let's solve this integral of cosine of 2t dt. We can introduce a substitution of s being equal to 2t, and that means that ds is 2 differentials of t. This is then equal to integral of cosine s dt is ds and 1/2 of it. Well, this basically means that we get 1/2 times a sine of s plus a constant c. C is a real number. When we return the substitution, we get that this is equal to 1/2 times sine of 2t plus c. So in our previous step, we get that this is equal to a squared divided by 2, open bracket t plus 1/2 of sine 2t plus a constant c. This constant is being added because we are doing an inbounded integral. And now we finally get that our integral a squared minus x squared under a square root dx is equal to a squared divided by 2 t plus 1/2 of sine 2t plus c. When we return the substitution according to t, we get that t is equal to arcus sine of x over a. And this means that we are getting a squared by 2 arcus sine of x over a plus 1/2 of sine of 2 arcus sine of x over a. Now this is then equal to a squared divided with 2 arcus sine of x over a plus a squared divided by 4. This is a sine of a double angle, so we are going to use a formula. Trigonometric formula for that is 2 times a sinus of arcus sine of x over a times a cosine of arcus sine of x over a. Closed bracket. And this is then equal to a squared over 2 arcus sine of x over a plus a squared by 2 sinus of arcus sinus of xa is x over a times a cosine of arcus sine of x over a. So our question now becomes, what is a cosine of arcus sinus of x over a? Well, a cosine squared of arcus sine of x over a plus a sine squared of arcus sine of x over a is equal to 1. This basically means that cosine squared of arcus sine of x over a is equal to 1 minus a sine of arcus sine of x over a squared, which is then equal to 1 minus sine of arcus sine of x over a is x over a, and that is squared. Which then leaves us with cosine of arcus sine of x over a being equal to a square root of 1 minus x over a squared. This is then equal to a square root of a squared minus x squared over a squared, which is then equal to 1 over absolute value of a square root of a squared minus x squared, which is then equal to 1 over a, because a is a positive number, square root of a to a squared minus x squared. And when we return all of this into our previous step, we get a solution of a squared divided by 2 arcus sine of x over a plus a times x divided by 2 times cosine of arcus sine of x over a is 1 divided by a square root of a squared minus x squared, which is then equal to a squared divided by 2 arcus sine of x over a plus x over 2 a square root of a squared minus x squared. And now we finally get that integral of a square root of a squared minus x squared dx is equal to a squared over 2 arcus sine of x over a plus x over 2 a square root of a squared minus x squared plus c, where c is a real number. Okay, let's now solve the same integral of square root a squared minus x squared dx using a second method, which is a partial integration. So let u be a square root of a squared minus x squared and dv be equal to dx. That means that du is equal to 1 over 2 square roots of a2 minus x2 times minus 2x dx, and v is equal to x. That basically means that du is equal to negative x over a square root of a squared minus x squared dx. So this integral is then equal to uv minus integral of v du, and that is equal to u v x square root of a squared minus x squared minus an integral of v du minus x squared dx over a square root of a squared minus x squared. This is then equal to x square root of a squared minus x squared minus an integral of negative a squared plus a squared minus x squared over a square root of a squared minus x squared dx, and that is basically equal to x square root of a squared minus x squared minus an integral of negative a squared over a square root of a squared minus x squared dx plus minus an integral of a squared minus x squared over a square root of a squared minus x squared dx. This is then equal to x square root of a squared minus x squared plus a squared integral of 1 over a square root of a squared minus x squared dx minus an integral of square root of a squared minus x squared dx. Let's say that I is equal to an integral of a square root of a squared minus x squared dx. Well, that basically means that we have this integral right here being equal to I. So I is equal to x squared root of a squared minus x squared plus a squared integral of 1 over a square root of a squared minus x squared dx minus I. And that means that 2I is equal to x square root of a squared minus x squared plus a squared integral of 1 over square root a squared minus x squared dx. So let's solve this integral. dx over a square root of a squared minus, this is then equal to an integral of dx over a square root of a squared, open bracket, 1 minus x over a squared. And this is then equal to integral of dx over a square root of a squared is a under an absolute value, a square root of 1 minus x over a squared, which is then equal to integral dx over, a was a positive number, so this is a times a square root of 1 minus x over a squared, which is then basically equal to 1 over a dx over a square root of 1 minus x over a squared. Now let's introduce a substitution of t being equal to x over a. Well, that means that dt is equal to dx over a. So this is then equal to an integral, dx over a is dt over square root of 1 minus t squared. And this is then equal to arcus sine of t, which is then equal to arcus sine t was x over a. Well, that basically leaves us with 2I being equal to x square root of a squared minus x squared plus a squared arcus sine of x over a. And then we have that I is equal to 1/2 of x square root of a squared minus x squared plus a squared arcus sine of x over a, and plus c, where c is a real constant. Okay, now I want to show the application of this integral which we have solved. So let's start with a square ABCD. Square has a side of a length of 4. Construct a quarter circle centered at B that connects A and C. Then construct a semicircle with a diameter AB. The quarter circle and the semicircle overlap. What is the area of the overlap between these two shapes? And this right here is the overlap. So we can solve this problem in a Descartes coordinate system. This is the x-axis and this is the y-axis. This is the center, 0. So let's denote these two circles which we have. Let the semicircle be denoted with C1 and let the quarter circle be denoted with C2. Basically that means that C1 has a center C1 with the coordinates side length of a square is 4. So B is at a 4 distance from A. Half of that is 2. And that means that C1 has coordinates of 2, 0. Now the diameter of this semicircle is equal to 2. Basically, that means that it has a formula of x minus 2 squared plus y squared equal to 2 squared. Now, the second circle C2, which we are dealing with, has a center at D. D is at a 4 distance from A, so that means that D has coordinates of 0, 4. A radius of this quarter circle is equal to 4, and that leaves us with its equation of x squared plus y minus 4 squared is equal to 4 squared. Now, to calculate this area of the overlap, we need to find the x-axis of this dot right here. This dot is in the intersection between C1 and C2. The second dot in its intersection is the beginning of the coordinate system, 0, 0. So this visible part of the circle C1 has an equation y squared is equal to 2 squared minus x minus 2 squared, which means that y is equal to a square root of 4 minus x minus 2 squared. The second solution of this problem is y is equal to a negative square root of 4 minus x minus 2 squared. Now, when we take a look at this circle C1, we see that we are dealing with an upper half of this circle respectful to the y-axis, and that leaves us with a positive solution, which is this solution right here. This negative part is below the y-axis, and we don't need that part because there is no intersection in that part with the circle C2. Now, a circle C2 has an equation of x squared plus y minus 4 squared is equal to 4 squared. That means that y minus 4 squared is equal to 4 squared minus x squared, which basically means that y minus 4 is equal to a plus or minus square root of 4 squared minus x squared. And that leaves us with the solution of y being equal to 4 plus minus a square root of 4 squared minus x squared. Now, when we look at the center of this circle C2, which is at point D, we see that we are dealing with the lower half of that circle, lower half according to its y-axis. Well, that basically means that we are dealing with the part which has an equation of y is equal to 4 minus a square root of 4 squared minus x squared. Now, in order to see which two dots are in the C1 intersection C2, we are basically going to have to solve a system of equations. Y is equal to a square root of 4 minus x minus 2 squared, and y is equal to 4 minus a square root of 4 squared minus x squared. So a part of the circle 1 which we are going to use has an equation of y is equal to a square root of 4 minus x minus 2 squared, and circle C2 has an equation of x squared plus y minus 4 squared is equal to 16. We have to intersect these two, so that means that x squared plus, now instead of y, we are going to write a square root of 4 minus x minus 2 squared minus 4 squared is equal to 16. Now this is x squared plus 4 minus x minus 2 squared minus 8 square root of 4 minus x minus 2 squared plus 16, which is equal to 16. And we can cancel out the 16s. This leaves us with the x squared plus 4 minus x squared plus 4x minus 4 minus 8 square root of 4 minus x minus 2 squared equal to 0. Now plus 4 and minus 4 are going to cancel out, and x squared and the negative x squared are going to cancel out. And we see that 4 is in common, so we can divide the entire equation by 4. And we are going to get that x is equal to 2 square roots of 4 minus x minus 2 squared. If we square the entire equation, we are going to get that x squared is equal to 4 minus x minus 2 squared. That means that x squared is equal to 16 minus 4x minus 2 squared. So x squared is equal to 16 minus 4 x squared minus 4x plus 4. So x squared is equal to 16 minus 4x squared plus 16x minus 16. 16 and negative 16 are going to cancel out. And then we get that x squared is equal to negative 4x squared plus 16x. That means that 5x squared minus 16x is equal to 0. X is in common, so we are left with 5x minus 16 being equal to 0. And that means that x is 0, or x is equal to 16 over 5. Well, basically that means that in our picture we have the following information. We have a square ABCD. We have a semicircle, and we have a quarter circle, and we have this overlap area which we have to see how much it is. This is the length of 4, and by solving this system of equations we get that 0 and 16 over 5 are x coordinates of the dots which represent the intersection of the borders of the overlap area. So the equation of the C1 border is y is equal to a square root of 4 minus x minus 2 squared. And the equation of the C2 border is y is equal to a 4 minus a square root of 4 squared minus x squared. Now, in order to calculate this area, we are going to use calculus. So we are left with an integral which goes from 0 to 16 over 5. The upper border is the C1, so we are left with a square root of 4 minus x minus 2 squared dx. And from that area, which is basically this area right here, we are going to exclude the area of this lower part, which has a boundary of C2, so that makes it an integral from 0 to 16 over 5. 4 minus a square root of 4 squared minus x squared dx. Basically, we have an integral from 0 to 16 over 5, square root of 4 minus x minus 2 squared dx. Let's introduce a substitution. T is equal to x minus 2, and that means that dt is dx. If x is equal to 0, that means that t is equal to negative 2, and if x is equal to 16 over 5, that means that t is equal to 16 over 5 minus 2, which is 16 over 5, minus 10 over 5, which is 6/5. Well, then this is equal to negative 2 to 6/5, a square root of 4 minus t squared dt, which is then equal to an integral of minus 2 to 6 over 5, a square root of 2 squared minus t squared dt. Now we already have found a solution of an integral of a squared minus x squared dx, and that was x over 2, a square root of a squared minus x squared, plus a squared over 2 arcus sine of x over a plus c, where c is a real constant. Now that basically means that in our integral which we have to solve, a is equal to 2. So we have the following. We have x over 2, a square root of 2 squared minus x squared, plus 2 squared over 2 arcus sine of x over 2. And all of that is happening in the borders from a minus 2 to 6 over 5. And then we are left over with 6 divided by 10, square root of 4 minus x squared. X is 6 over 5 squared, plus 2 arcus sine of 6 over 10, minus negative 2 over 2 square root of 4 minus 4, plus 2 arcus sine of negative 1. And then this is equal to 3/5, a square root of 100 over 25 minus 36 over 25, plus 2 arcus sine of 3 over 5 minus arcus sine of negative 1. This is equal to 0. So this is equal to 3 over 5 times 8 over 5 plus 2 arcus sine of 3 over 5 minus arcus sine of negative 1. This is basically equal to 24 over 25 plus 2 arcus sine of 3 over 5 minus arcus sine of minus 1. Now a second integral which we have to solve is an integral from 0 to 16 over 5, 4 minus a square root of 4 squared minus x squared dx, which is then equal to 4 times an integral from 0 to 16 over 5 dx minus an integral from 0 to 16 over 5, a square root of 4 squared minus x squared dx, which is then equal to. We have already solved an integral from a square root of a squared minus x squared dx, and that was equal to x over 2, a square root of a squared minus x squared plus a squared over 2 arcus sine of x over a plus c, where c is a real number. Now this is equal to, in this integral, a is equal 4, so this becomes 4 times x in the borders of 0 to 16 over 5 minus x over 2, a square root of 4 squared minus x squared plus 4 squared over 2 arcus sine of x over 4 in the borders from 0 to 16 over 5. This is then equal to 4 times 16 over 5 minus 16 over 10 square root of 4 squared minus 16 over 5 squared plus 4 squared over 2 arcus sine of 16 over 20 minus 0 over 2 a square root of 4 squared minus 0 squared minus 4 squared over 2 arcus sine of 0 over 4. This is equal to 0 and this is equal to 0. So we have that this is equal to 4 times 16 over 5 minus 16 over 10, a square root of 4 squared minus 16 over 5 squared minus 8 arcus sine of 4 over 5, which is then equal to 64 over 5 minus 8 over 5, square root of 16 minus 256 over 25 minus 8 arcus sine of 4 over 5, which is then equal to 64 over 5 minus 8 over 5 times 400 minus 256 over 25 minus 8 arcus sine of 4 over 5, which is then equal to 64 over 5 minus 8 over 5 times a square root of 144 over 25 minus 8 arcus sine of 4 over 5, which is then equal to 64 over 5 minus 8 over 5 times 12 over 5 minus 8 arcus sine of 4 over 5, which is then equal to 320 minus 96 over 25 minus 8 arcus sine of 4 over 5, which is then equal to 224 over 25 minus 8 arcus sine of 4 over 5. Now when we return these two values from these integrals which we have calculated, we get that this is equal to 24 over 25 plus 2 arcus sine of 3 over 5 minus 2 arcus sine of negative 1 minus, and the integral we have calculated previous was minus 224 over 25 plus 8 arcus sine of 4 over 5. And when we calculate all of this, it gives us the value of approximately 3.84696. So this number is the area of the overlap. If you have watched this video so far, I suspect that you have found it to be somewhat useful. I'm looking forward to reading your comments and suggestions. Please subscribe to the channel if you want to see more problems like this getting solved. I suggest that you watch my next video, which I have linked here.